In the previous two videos, we discussed how postsynaptic potentials generate dipoles. This electrical activity forms the basis of EEG recordings. In this video, we will walk through how these dipoles are summed together in order to be read by sensors at the scalp. A single dipole, generated by the postsynaptic potentials of a single neuron, is generally too weak for an electrode on the scalp to detect. However, the summed synchronous activity of thousands of dipoles will produce a measurable signal. This summation relies on two factors. 1. The timing of neural activity, and 2. The orientation of the neurons. When neurons fire at different times, the dipoles do not sum together as easily and the overall signal is weak. But look what happens when they fire at the same time. One can think of synchronous dipoles as a choir, harmonizing together to form a stronger EEG signal. However, neurons firing at the same time is not the only factor that affects the EEG signal. In addition, the position of the neurons plays an important role. When the neurons are in opposite alignment, the positive and negative charges of their respective dipoles neutralize each other. When the neurons are oriented like this, even though they are firing at the same time, EEG sensors will not pick up a signal. Observe what happens when neurons are scattered in their alignment. Some of the signal is neutralized, but some is able to reach the scalp. Thus, varied dipole alignment only produces a weak signal. The strongest signal is generated when neurons are aligned in the same orientation. Here you can see how the dipole charges are able to sum together, generating a more powerful EEG signal. These videos have explored the nature of intercellular signaling. By understanding the relationship between action potentials, postsynaptic potentials, and dipoles, we can begin to understand how a tiny signal lasting no more than a second generates EEG waveforms, which in turn give us valuable insight into the complex processing of the brain.